As our final consideration of amino acids, let's take a look at the bond that results from connecting them together. This is the first consideration of protein structure, which we will examine in greater detail in the next chapter. A peptide bond, that is the bond connecting amino acids within a peptide, is actually an amide functional group. It is a covalent bond formed between the alpha carboxyl group of one amino acid and the alpha amine of a second. Peptides contain a minimum of 2 amino acids and may contain as many as a few dozen, all connected by peptide bonds. Any molecule containing more than a few dozen residues would be considered a protein rather than a peptide. As we look at the polypeptide chain formed by linking the component amino acids by peptide or amide bonds, we can see that this is the backbone of the structure, with the amino acid side chains, or R groups, pointing out from the backbone. We most often represent the carbonyl carbon as singly bonded to the adjacent amine nitrogen. However, since the carbon in this bond is double bonded to an oxygen, and the adjacent nitrogen carries a lone pair of electrons, a resonance structure exists. We might also represent the bond between the carbon and nitrogen as a double bond, and the oxygen atom in this case would carry a net negative charge, as illustrated here. The more accurate way to think of the peptide bond is to consider it a hybrid of these two structures. This means that the peptide bond is partially double bonded and therefore has a shorter bond length and a stronger bond than in the case of a single bond. In fact, the bond is sufficiently strong to prevent free rotation within the bond. This will be our first consideration as we consider protein structures in greater detail. In addition to peptide bonds, other covalent bonds are also possible. Two examples are the hormones oxytocin and vasopressin. As you can see from the structures represented here, they each carry 2 cysteine residues that can be oxidized to form a joint disulfide bond. As we proceed, we'll see that the capacity of cysteine residues to form these oxidized bonds plays an important role in the native structures of peptides and proteins.